Reforestation is the practice of restoring previously existing forests and woodlands that have been destroyed or damaged. The prior forest destruction might have happened through deforestation, clearcutting, or wildfires. Three important purposes of reforestation programs are for harvesting of wood, for climate change mitigation, and for ecosystem and habitat restoration purposes. One method of reforestation is to establish tree plantations, also called plantation forests. They cover about 131 million ha worldwide, which is 3% of the global forest area and 45% of the total area of planted forests. Globally, planted forests increased from 4.1% to 7% of the total forest area between 1990 and 2015. Plantation forests made up 280 million hectare in 2015, an increase of about 40 million ha in the previous 10 years. Of the planted forests worldwide, 18% of that area consists of exotic or introduced species, while the rest consist of species native to the country where they are planted. There are limitations and challenges with reforestation projects, especially if they are in the form of tree plantations. Firstly, there can be competition with other land uses and displacement risk. Secondly, tree plantations are often monocultures, which comes with a set of disadvantages, for example biodiversity loss. Lastly, there is also the problem that stored carbon is released at some point. The effects of reforestation will be farther in the future than those of perforestation, the conservation of intact forests. Instead of planting entirely new areas, it might be better to reconnect forested areas and restore the edges of forest. This protects their mature core and makes them more resilient and longer lasting. It takes much longer, several decades, for the carbon sequestration benefits of reforestation to become similar to those from mature trees in tropical forests. Therefore, reducing deforestation is usually more beneficial for climate change mitigation than is reforestation. Many countries carry out reforestation programs. For example, in China, the 3 Northern Protected Forest Development Program, informally known as the Great Green Wall, was launched in 1978 and scheduled to last until 2050. It aims to eventually plant nearly 90 million acres of new forest in a 2,800-mile stretch of northern China. Such programs often blur the boundaries between reforestation and afforestation, the latter being the establishment of a forest in an area where there was no forest before. Reforestation, according to the IPCC, means the conversion to forest of land that has previously contained forests but that has been converted to some other use. According to FAO terminology, reforestation is defined as the re-establishment of forest through planting and/or deliberate seeding on land classified as forest. Afforestation, on the other hand, means establishing new forest on lands that were not forest before, for example, abandoned agriculture. It is the process of restoring and recreating areas of woodlands or forests that may have existed long ago but were deforested or otherwise removed at some point in the past or lacked it naturally, for example, natural grasslands. Purposes. Reforestation is not only used for recovery of accidentally destroyed forests. In some countries, such as Finland, many of the forests are managed by the wood products and pulp and paper industry. In such an arrangement, like other crops, trees are planted to replace those that have been cut. The Finnish Forest Act from 1996 obliges the forest to be replanted after felling. In such circumstances, the industry can cut the trees in a way to allow easier reforestation. Reforestation, if several indigenous species are used, can provide other benefits in addition to financial returns, including restoration of the soil, rejuvenation of local flora and fauna, and the capturing and sequestering of 38 tons of carbon dioxide per hectare per year. There are 4 primary ways in which reforestation and reducing deforestation can increase carbon sequestration and thus help with climate change mitigation. First, by increasing the volume of existing forest. Second, by increasing the carbon density of existing forests at a stand and landscape scale. Third, by expanding the use of forest products that will sustainably replace fossil fuel emissions. Fourth, by reducing carbon emissions that are caused from deforestation and degradation. Forests are an important part of the global carbon cycle because trees and plants absorb carbon dioxide through photosynthesis. Therefore, they play an important role in climate change mitigation. By removing the greenhouse gas carbon dioxide from the air, forests function as terrestrial carbon sinks, meaning they store large amounts of carbon in the form of biomass, encompassing roots, stems, branches, and leaves. Throughout their lifespan, trees continue to sequester carbon, storing atmospheric CO2 long-term. Sustainable forest management, afforestation, reforestation are therefore important contributions to climate change mitigation. An important consideration in such efforts is that forests can turn from sinks to carbon sources. In 2019, forests took up a third less carbon than they did in the 1990s, due to higher temperatures, droughts, and deforestation. The typical tropical forest may become a carbon source by the 2060s. Researchers have found that, in terms of environmental services, it is better to avoid deforestation than to allow for deforestation to subsequently reforest, as the former leads to irreversible effects in terms of biodiversity loss and soil degradation. Furthermore, the probability that legacy carbon will be released from soil is higher in younger boreal forest. Global greenhouse gas emissions caused by damage to tropical rainforests may have been substantially underestimated until around 2019. Additionally, the effects of afforestation and reforestation will be farther in the future than keeping existing forests intact. It takes much longer, several decades, for the benefits for global warming to manifest to the same carbon sequestration benefits from mature trees in tropical forests, and hence from limiting deforestation. Therefore, scientists consider the protection and recovery of carbon-rich and long-lived ecosystems, especially natural forests, to be the major climate solution. The planting of trees on marginal crop and pasture lands helps to incorporate carbon from atmospheric CO2 into biomass. For this carbon sequestration process to succeed, the carbon must not return to the atmosphere from biomass burning or rotting when the trees die. To this end, land allotted to the trees must not be converted to other uses. Alternatively, the wood from them must itself be sequestered, example via biochar, bioenergy with carbon capture and storage, landfill, or stored by use in construction. Plantation forests are intensively managed, composed of one or two species, even-aged, planted with regular spacing, and established mainly for productive purposes. Other planted forests, which comprise 55% of all planted forests, are not intensively managed, and they may resemble natural forests at stand maturity. The purposes of other planted forests may include ecosystem restoration and the protection of soil and water values. Plantation forests cover about 131 million ha, which is 3% of the global forest area and 45% of the total area of planted forests. Over 90% of the world's forests regenerate organically, and more than half are covered by forest management plans or equivalents. Globally, planted forests increased from 4.1% to 7% of the total forest area between 1990 and 2015. Plantation forests made up 280 million hectare in 2015, an increase of about 40 million ha in the previous 10 years. Of the planted forests worldwide, 18% of that planted area consists of exotic or introduced species, while the rest consist of species native to the country where they are planted. A tree plantation, forest plantation, plantation forest, timber plantation, or tree farm is a forest planted for high-volume production of wood, usually by planting one type of tree as a monoculture forest. The term tree farm also is used to refer to tree nurseries and Christmas tree farms. Plantation forestry can produce a high volume of wood in a short period of time. Plantations are grown by state forestry authorities, for example, the Forestry Commission in Britain, and/or the paper and wood industries and other private landowners, such as Weyerhaeuser, Rayonier, and Sierra Pacific Industries in the United States or Asia Pulp and Paper in Indonesia. Christmas trees are often grown on plantations, and in southern and southeastern Asia, Teak plantations have recently replaced the natural forest. Industrial plantations are actively managed for the commercial production of forest products. Industrial plantations are usually large-scale. Individual blocks are usually even-aged and often consist of just one or two species. These species can be exotic or indigenous. The plants used for the plantation are often genetically altered for desired traits such as growth and resistance to pests and diseases in general and specific traits, for example in the case of timber species, volumic wood production and stem straightness. Forest genetic resources are the basis for genetic alteration. Selected individuals grown in seed orchards are a good source for seeds to develop adequate planting material. Wood production on a tree plantation is generally higher than that of natural forests. While forests managed for wood production commonly yield between 1 and 3 cubic meters per hectare per year, plantations of fast-growing species commonly yield between 20 and 30 cubic meters or more per hectare annually. A grand fir plantation in Scotland has a growth rate of 34 cubic meters per hectare per year, and Monterey pine plantations in southern Australia can yield up to 40 cubic meters per hectare per year. In 2000, while plantations accounted for 5% of global forest, it is estimated that they supplied about 35% of the world's roundwood. Planting new trees often leads to up to 90% of seedlings failing. However, even in deforested areas, existing root systems often exist. Growth can be accelerated by pruning and copicing, where a few branches of new shoots are cut and often used for charcoal, itself a major driver of deforestation. Since new seeds are not planted, it is cheaper. Additionally, they are much more likely to survive as their root systems already exist and can tap into groundwater during harsher seasons with no rain. While this method has existed for centuries, it is now sometimes referred to as farmer-managed natural regeneration or assisted natural regeneration. Policies that promote reforestation for incentives in return have shown promising results of being an effective and motivative concept to replant globally on a mass scale. Some incentives for reforestation can be as simple as a financial compensation. A compensated reduction of deforestation approach has been proposed, which would reward developing countries that disrupt any further act of deforestation. Countries that participate and take the option to reduce their emissions from deforestation during a committed period of time would receive financial compensation for the carbon dioxide emissions that they avoided. To raise the payments, the host country would issue government bonds or negotiate some kind of loan with a financial institution that would want to take part in the compensation promised to the other country. The funds received by the country could be invested to help find alternatives to the extensive cutdown of forests. This whole process of cutting emissions would be voluntary, but once the country has agreed to lower their emissions, they would be obligated to reduce their emissions. However, if a country was not able to meet their obligation, their target would get added to their next commitment period. The authors of these proposals see this as a solely government-to-government agreement. Private entities would not participate in the compensation trades. Another emerging revenue source to fund reforestation projects deals with the sale of carbon sequestration credits, which can be sold to companies and individuals looking to compensate their carbon footprint. This approach allows for private landowners and farmers to gain a revenue from the reforestation of their lands, while simultaneously benefiting from improved soil health and increased productivity. Alongside past financial incentive strategies, reforestation tax benefits have been another way the government has encouraged companies to promote reforestation tactics through the promises of a tax break. As many landholders seek to earn carbon credits through sequestration, their participation also encourages biodiversity and provides ecosystem services for crops and livestock. There is often insufficient integration between the different purposes of reforestation, namely economic utilization, enhancement of biodiversity and carbon sequestration. This can lead to a range of different challenges. Competition with other land uses and displacement risk. Reforestation can compete with other land uses, such as food production, livestock grazing, and living space, for further economic growth. 46-47 Reforestation can also divert large amounts of water from other activities. A map created by the World Resources Institute in collaboration with the IUCN identifies 2 billion hectares for potential forest restoration and is criticized for including 900 million hectares of grasslands. An assessment of the pledges of governments for reforestation found that the sum of global pledges translates to a required land area of 1.2 billion hectares, until 2060, which is equal to a tenth of the global land area and thus deemed unrealistic without a significant encroachment on non-forest areas. Experts are calling for a better integration of social data, such as the dependence of livelihoods on specific land uses, into restoration efforts. Possible solutions include the integration of other land uses into forests through agroforestry, such as growing coffee plants under trees, reducing the delineation between forests and other land uses. A study found that almost 300 million people live on tropical forest restoration opportunity land in the global south, constituting a large share of low-income countries' populations, and argues for prioritized inclusion of local communities in forest restoration projects. There are calls for a more selective approach to identifying reforestation areas, taking into account the possible displacement of customary land uses. Reforesting sometimes results in extensive canopy creation that prevents growth of diverse vegetation in the shadowed areas and generating soil conditions that hamper other types of vegetation. Trees used in some reforesting efforts, for example, Eucalyptus globulus, tend to extract large amounts of moisture from the soil, preventing the growth of other plants. The European Commission found that, in terms of environmental services, it is better to avoid deforestation than to allow for deforestation to subsequently reforest, as the former leads to irreversible effects in terms of biodiversity loss and soil degradation. The effects reforestation has on biodiversity is not limited to just other forms of vegetation, it can affect all forms of living organisms all contained in the present ecosystem. Due to the major role trees have on ecosystems, it is important to better understand components like the ecosystem, waterways, and species present in areas that are being replanted. Prior research helps limit the depletion of biodiversity, which can hinder medicinal discoveries, and alter gene flow in organisms. A debated issue in managed reforestation is whether the succeeding forest will have the same biodiversity as the original forest. If the forest is replaced with only one species of tree and all other vegetation is prevented from growing back, a monoculture forest similar to agricultural crops would be the result. However, most reforestation involves the planting of different selections of seedlings taken from the area, often of multiple species. There is also the risk that, through a forest fire or insect outbreak, much of the stored carbon in a reforest area could make its way back to the atmosphere. Furthermore, the probability that legacy carbon will be released from soil is higher in younger boreal forests. An example of this can be seen in the peatlands in Central Africa, which house an abundance of carbon in the mud called peat. Much like the forest fire or insect outbreak which can harm tropical rainforests, money can also be seen an incentive to harm forests and be paid off to protect it. The global greenhouse gas emissions caused by damage to tropical rainforests may be underestimated by a factor of 6. Also, the possible harvesting and utilization of wood from reforest areas limits the permanence of carbon sequestered through reforestation. For example, it was found that nearly half of the pledges under the bond challenge were areas earmarked for commercial wood use. Additionally, the effects of afforestation and reforestation will be farther in the future than those of preforestation, the conservation of intact forests. It takes much longer, several decades, for the benefits for global warming to manifest to the same carbon sequestration benefits from mature trees in tropical forests and hence from limiting deforestation. Some researchers note that instead of planting entirely new areas, reconnecting forested areas and restoring the edges of forest, to protect their mature core and make them more resilient and longer lasting, should be prioritized. Implementation challenges. There are some implementation challenges. Seed shortage. The Seed to Forest Alliance was founded in 2022 in response to a global seed shortage. It will promote the establishment of national seed banks, while focusing on the tropics and biodiversity hotspots. Seedling survival rate. A common challenge for reforestation is the low survival rate of seedlings. Planted trees often do not mature, for example due to difficult climatic conditions or insufficient care after planting. Some organizations and programs. Ecosia is a non-profit organization based in Berlin, Germany, that has planted over 100 million trees worldwide as of July 2020. Trees for the Future has assisted more than 170,000 families, in 6,800 villages of Asia, Africa, and the Americas, to plant over 35 million trees. Ecology is an organization that offers its members ways to support climate change solutions. This includes offsetting their carbon emissions and tree planting. So far over 50 million trees have been planted through ecology, as well as more than 2.2 million tons of CO2 reduced. Wangari Maathai, 2004 Nobel Peace Prize recipient, founded the Green Belt movement which planted over 47 million trees to restore the Kenyan environment. Team Trees was a 2019 fundraiser with an initiative to plant 20 million trees. The initiative was started by American YouTubers MrBeast and Mark Rober, and was mostly supported by YouTubers. The Arbor Day Foundation will work with its local partners around the world to plant one tree for each dollar they raise. Trees for Life, Brooklyn Park, is a state-based organization, which was established back in 1981 and delivers conservation, revegetation, and community training programs. It now has thousands of active supporters and energizes activity within communities. Many companies are trying to achieve carbon offsets by nature-based solutions like reforestation, including mangrove forests and soil restoration. Among them are Microsoft and ENI. Increasing the forest cover of Earth by 25% will offset the human emissions in the last 20 years. In any case, it will be necessary to pull from the atmosphere the CO2 that already have been emitted. However, this can work only if the companies will stop new emissions and stop deforestation. The 2020 World Economic Forum, held in Davos, announced the creation of the Trillion Tree Campaign, which is an initiative aiming to plant 1 trillion trees across the globe. The implementation can have big environmental and societal benefits but needs to be tailored to local conditions. The forest landscape restoration strategy seeks to rehabilitate landscapes and repair marginal and degraded areas in order to generate productive forest landscapes that are resilient and long-term. It aims to guarantee that diverse ecological and land use functions are restored, safeguarded, and preserved over time. Thank you for watching this video.